Now, excess and unstable wind and solar power generation are exposing Kenya to the blackouts recently experienced in the country as national utility Kenya Power walks a tightrope balancing growing power demand against current supply. NTV's Brian George now explains what Kenya Power is doing to avert this problem.
KPLC says a careful balance is needed when onboarding variable renewable energy VRE sources to mitigate their impact on the grid. The intermittency of VREs, wind and solar, affects the reliability and quality of power supply since it disrupts the frequency and voltage of the electricity delivered.
A grid is very unstable when there is a lot of variability. And one would always require to have a mechanism of mitigating that variability. And the variability, at worst, can cause a grid collapse. And at best, it can cause power quality challenges, which to someone just using power for lighting purposes may not appear like it's impacting in any way. But for the industry, which are so frequency sensitive, at times that variability might mean they have lost everything that was being manufactured on that particular day.
Our power grid stability depends on two main things, that is the power generation and demand of the same. At any point, engineers monitor voltage and frequency of this power. So if at any point there is an inverse proportion of either demand or supply over demand, then the grid has to trip. In layman's, that is called a power outage. So think of it as a reflex action of the whole grid in maintaining the facility and not having a total destruction of that. But remember, at the core of this is monitoring of both voltage and the frequency of the power.
VREs currently make up 34% of the total energy mix during peak daytime demand of 1,900 megawatts and 36% during low load demand of 1,200 megawatts. Compared to other countries, Kenya has the highest dependency on VREs in the region. Within the Eastern Africa Power Pool, for example, Egypt's VRE quantum stands at 10.4%, Ethiopia's at 5.3%, Uganda's at 4%, and Tanzania's at 1.2%. Kenya's baseload power, made up of geothermal, hydro, power imports and thermal, currently account for 80% of the grid's energy mix. The company has also called for increased baseload generation, which is more stable and less prone to dips in production.
If at a particular instance, and let me use solar because it's one of the classic cases of a VRE, a cloud or it starts raining heavily, then if the solar was contributing 200 megawatts, instantaneously it will drop to near zero. And we have had many of those cases. The moment it drops near zero, what happens? You have a demand of 1,600, but now the generation is 1,400. There is an imbalance between what is being demanded and what is being generated. How it manifests, there will be a frequency dip. And if that dip is too deep, for lack of a better way of illustrating it, you will actually lose the grid. Of course, at best at times, the grid might recover, and the way it does, it knocks off some of the loads just to be able to ensure that now what is being demanded by the grid is, say, at 1,400, so it has to knock off the extra 200, which means some places go off.
The power distributor will also pursue liquefied natural gas generation in phases to ramp up its energy mix and curb intermittent supply to the national grid. Brian George, NTV, Nairobi.